Hello everyone and welcome to Teachopedia. Today we will be learning about how to predict COVID-19 confirmed cases and fatalities using machine learning models. And in machine learning we will be using time series forecasting for that. So let's jump straight into it. So I will be working on Kaggle notebook, and first of all let's learn about what is coronavirus and what is this pandemic all about. So, according to the research, it was first isolated in 1937. The scientists first found it first evidence in human in 1960s in the noses of people with common cold symptom. So after that, the name coronavirus come from crown-like projection on their surfaces. Corona in Latin means halo or crown. Among humans, corona infection must often occur during the winter and early spring seasons. And this is because coronavirus antibodies do not last for long. Also, the antibodies of one strain of coronavirus may infect against another one. Okay, so now moving on, this coronavirus pandemic, which is ongoing in our world, its first outbreak was in Wuhan, China in December 2019, and it's also called SARS-CoV-2, which means that it's syndrome coronavirus 2. Okay, and it was recognized as a pandemic by the WHO or World Health Organization on March 11, 2020. As of 18 April, more than 2 million cases have been reported in more than 200 countries, resulting in 150,000 deaths and 560,000 have been recovered. So you can check this worldometer coronavirus for to get some more information about the figures. So this coronavirus symptoms, common symptoms may be fever, tiredness, dry cough. Other symptoms may include pain in chest, runny nose, sore throat, and diarrhea. On average, it takes 5 to 6 days for its symptoms to show in the human body, and it often takes 14 days to show all of the symptoms. So, moving on, we will be using time series modeling to forecast the future cases which will be reported in coming days and the fatalities which will be which can occur in future. So we will be focusing on time series model. And in time series, we have different models like ARIMA and SARIMA models. They both belong to the ARMA models, ARMA models, which usually called. So if you are confused, don't worry, let me explain one by one. First of all, what is ARMA? In time series, we have different models, and as I said, ARIMA and SARIMA models both belong to the concepts of ARMA models. Think of ARMA models like we have to predict tomorrow confirmed cases, to confirm corona cases in a country. So for that, we will be taking its previous month records and data, and we will also consider the error rate of that time period. In ARMA, we have two things, AR and MA. AR represent autoregression and MA represent moving average, which related to error rate. So now ARIMA includes another thing which is I. And what is this? It's basically related to integration, or you can say integrated. So now we have AR, autoregression, then we have I integrated, and then we have moving average, which is MA. And this combine, which we call it ARIMA model. So it's one of the class of this statistical model for analyzing and forecasting time series data. And what this does is we often usually have these type of data. As you can see in the image, we have moving average, or you can say moving mean. So we need to have a constant mean for that. And for that, we usually take a difference of data so that after a few iterations, we have a constant mean, like in this figure. We have a constant mean of our data, and then we can apply ARMA model on that. So when we combine these two things, ARMA and we came across ARIMA model. We have different parameters in ARIMA like P, D, and Q. P represent the number of lag observations, like the observation which we have to consider previous for previous days. D represents the difference, and Q represent the moving average window. So now ARIMA models can't be used with seasonal data. When we have seasons data like 3 months data or quarterly based data, we need to use SARIMA models, which cater seasons data because it has additional parameters in it which represent seasons. So we have now P, D, Q, and M, and also we have P, D, Q of trend data also. So now P represent the small p represent the trend autoregression, then D which is difference, and Q which is the moving average. And now we have additional four parameters of season elements. Then in season elements we have P which is a autoregressive order, season autoregressive order, and then we have D which is season difference order, and then we have Q which is season moving average order, and then we have M which is related to number of time or steps for a single season period. This is its representation. So now let's work on the coding side and implement these time series forecasting models. But first, let's import some libraries which will be helpful in our case and in this scenario. We are using these train and test CSV files from COVID Global Forecasting Week 4, which is an ongoing Kaggle competition. And then we will print its head just to check whether it's imported successfully or not. In the pre-processing file, we are converting a date time, which is an object, to date time type. And we are taking it and setting the index as a date. So just to check what it look like. So it will print date wise every column, the remaining column, which is confirmed cases, fatalities, country, region, etc. So now we have some null values in the proven state. So we will be filling that with fillna, which is a panda function. So as you can see, we have null values in proven state. So we will be resolving that issue with fillna and insert an empty string in those places. So as you can see, we now don't have any null values. So moving on, we will be removing and dropping these two columns from test and training data. And then we will be printing some chart just to check how it looked like. So this will print a chart of top 40 countries which have the highest number of confirmed cases. So it will print by country region which have the most reported cases. So on the first we will have the largest one. As you can see right now it's US, then we have China, then we have Italy, and so on. Same case we will apply with fatalities. As you can see, Italy is on the top, then we have US, and then we have Spain. So now let's plot a different chart this time, and let's see how it look like. So now we have now a world map, and what we can do is we can increase this date, it will print how it spread around in the world. Same thing we apply with fatalities as well. So cool. We have something to visualize and we have now some idea about how it spread in the world from January till April till now. Now we will use forecasting models and try to predict the upcoming days, confirmed cases and fatalities. So now as you can see, I just applied this thing for Pakistan because this model usually takes some time, and I have used Sarima for our case. You can use ARIMA as well just to check out its result. Just place this thing into this and it will work out exactly the same. And we are printing next 13 to 14 days data. So for this, we have first our confirmed cases scenario, and then we have fatalities forecasting. So we are focusing on one country. So let's change from Pakistan to Turkey, and let's forecast its upcoming data and check whether it's worked or not. I think it's worked pretty much fine and give us some decent results. This is the fatalities column and this is the confirmed cases column. So now let's save this and so let's print some plot Turkey data and print plot confirmed cases by date, and we will be using plotly for that. Yes, it's work and it give us total confirmed cases by date. So now we are in the second part of this forecasting COVID-19 data, and in this we are extracting data, global data of deaths, recovered and confirmed cases from these three different URLs, and this gave us confirmed cases, deaths and recovers, and from that we will find out the active number of cases in each countries. So let's first download these data sets and print its heads. As you can see, we have now a date column wise and the number of cases column wise. So now we need to change this column into row wise. We usually use meld function of pandas library for these type of things which behave like a pivot, and it changed the data frame format from wide to long. So let's apply first this, and for that we will be needing dates. How many dates are present in these three different data sets? So from that we will get our date. So after getting all the dates which are present in these data sets, we first apply on the global confirmed cases just to check how it look like. So we need to convert these dates from raw from one raw into multiple rows. So for that we will be needing a date column and convert all these values and put it in the confirm column. So this is how it's format, and we will write this thing in Python, and this is its output for each date, and for each country it has its confirm cases. So same goes for deaths and recover data frames, and we will meld these datas, and then we are merging the confirmed case data frame with the data frame, and then we merge them with recovered data frame. So as you can see, proven state, country, region, lat, long are same in all of these data sets. So after this melting function, we apply the same case with confirmed cases, deaths, and recovered data frames and data, and meld these other two data as well. And then we apply merged first on confirmed cases and deaths, and then on the result after merging these two, and then we merge with recovered data set, or you can say data frame. So in the data frame, in the merge thing, we used these column which act as a join. So when we apply join in between two data frame, we have to define on what variables or what columns we are joining these two data. So we are joining on the basis of this, and then we have complete data in this complete data variable, and this is its shape of confirm deaths and recover data frame, and this is the output of complete data. And then we identify the active cases by subtracting recovered and deaths with confirmed cases. So now we have, okay, so now we have cases of deaths, recovered, confirmed, and active as well. So moving on, we will check for the null values in our complete data. So we have something in recovered and active as well. So we tackle them both exactly the same and fill with zeros. And now we don't have any null values, but we have some null values in the state. So we just ignore that. It doesn't matter, especially in our case. And we are now changing some country names which are typically wrong written in our data. So let's change it. And now let's visualize some of our data and confirm and death and recovered cases. So as you can see, this is access is kind of messy, but you will get some idea about the cases worldwide. So moving on, we will check the top rated countries which have the most deaths occurred in their countries. So we had on top of that, Italy's at the first place, and then we have USA and Spain. And then now we will forecast this data, and for right now we are focusing on only Turkey, but you can replace this thing and forecast for all of the countries. So just print it out, and we are forecasting for next 13 to 14 days, and we are forecasting recovered cases. You can check, you can change this recovered to deaths and confirmed cases, but this was a kind of idea which my goal was to give you and to share with you. So I hope you enjoy this forecasting tutorial and time series little bit background about what is time series model and how we can apply time series model in this scenario in which we are forecasting COVID-19 confirmed cases and fatalities. So if you have any queries, do let me know, and thank you so much.